Welcome to the Stormsurf video surf forecast for the week starting Saturday, March 4th. Looking at significant wave heights for the North Pacific Ocean, we see a somewhat improved pattern compared to a week ago. Low pressures in the Gulf of Alaska, generating a small area of 20-foot seas just barely, and a broader low is developing over the dateline, producing 24-foot seas, aimed pretty well at Hawaii, and yet another low is developing over the Kuril Islands, but all its seas are basically behind the Kuril Islands and not producing any waves of interest. Let's get into the details. As usual, we'll start our tour taking a look at jet stream level winds. These winds up about 30,000 feet help support the formation of gales, and when those gales form, help direct their track. We're looking for a trough. That is a dip in the jet, just like right here. That helps support a counterclockwise flow aloft, which is the hallmark of low pressure. That flow also occurs down at the surface, and of course low pressure generates wind. Winds generate seas. Seas, as they radiate away from the fetch area, produce swell, and swell, when it hits your beach, makes waves. All right, so we have one trough in action here. Notice the jet. Actually, let's back off. The jet's coming off Japan, moving at, what is that, about 150 knots, but over a very thin, small area, running basically flat to the east, making it to a point north of Hawaii, and then it splits. Notice the southern branch heads down towards the equator. The northern branch heads up towards the Bering Sea. That is creating this little trough here, and that's good to support low pressure. And sure enough, we saw on the significant wave height chart that there is something going on there, producing, what would we say, 24-foot seas or so, aimed at Hawaii. Also notice we have another trough here in the Gulf of Alaska. That is being supported by 130 knot winds. Low pressure is there, for sure, we know that, and a little area of 20-foot seas. So all this is cohesive, makes pretty good sense. Also notice the jet is pushing into Northern California, Cape Mendocino area. That is probably a good sign of precipitation there, and we'll see how this plays out. So let's just put the models in motion. Then we move into Saturday night, Sunday. Notice the trough in the Gulf falls south almost to San Francisco. Strong winds moving into interior U.S. at 130 to 140 knots. Trough somewhat holds here on the dateline. We'll just roll that out, but notice it kind of falls apart a little bit, but a secondary trough, just a little dip right there, still is supportive of gale development. As we get into Monday, though, notice the jet in over the U.S. West Coast starts moving north, and that's probably the end of the weather event for California. Roll this out. Sure enough, there we go. Another trough. I know it's a little bit of a split here, but probably enough there. I'll call it a secondary trough, enough to probably support some sort of gale development. And then we get into Tuesday night, early Wednesday, and then notice winds pick up very strong off Japan to 180 knots, but the jet splits heavily. Now, why is the jet splitting? And notice it was split earlier, somewhere around north of Hawaii or so. Why is the jet splitting? Typically, that has to do with the phase of the MJO, the inactive phase of the MJO. When it's over in this region, wherever it is, north of it in winter months, that's where the effect it has on the jet stream is most noticeable. In this case, the inactive phase of the MJO is somewhere over in this region. That steals energy from the jet. That causes it to split because it doesn't have just enough force to just bull its way across the Pacific. Likewise, when the active phase of the MJO is, say, in the West Pacific, it feeds the jet stream, makes it stay consolidated, push further across the Pacific, and then increases the odds for storm development. Once the jet splits, between the two splits of the jet stream, you typically get high pressure, and that is certainly not good for storm or swell production. The weird thing this year, though, is the jet has been split a fair amount because of La Nina. La Nina favors or puts a bias in the atmosphere in favor of the inactive phase of the MJO. The inverse is true. When El Nino is in control, it tends to favor the active phase of the MJO, which tends to feed the jet, which tends to create more storm production and therefore more surf and more snow and all that sort of stuff. The weird thing is this year, the jet, we've been in La Nina, very weak La Nina. The inactive phase of the MJO has been there, but not super strong. But generally, the MJO has just been non-existent. Okay, and the jet splits. But what's been happening is the split point's been out here in the West Pacific. It's been a westward displaced La Nina, which means it tends to be out here. The inactive phase of the MJO and the cold water associated with La Nina has been out here. The jet has split it out here. So then what happens is it splits, but then it sort of regroups and pushes onshore right off California, and that's what has been enhancing storm production in terms of precipitation moving into California, U.S. West Coast, making lots of water and, of course, lots of snow. Anyway, so let's continue on. We diverted there just a little bit. Split jet, very much split, sort of a backdoor trough here on Wednesday night off of Canada. And notice again, we get into Friday. And now this is a new development in the models just in the past 24 hours. The jet sort of seems to try to come together, tries to reconsolidate, pushing again onshore over central California. Again, potential for weather. This has been the pattern all season. The models say no rain, no nothing in California, and then 3 days later, all of a sudden, whoa, look at this. We got a onshore jet stream flow, and this is looking pretty good. Look into Saturday here. Another strong jet, not really a backdoor trough, but there's the north, there's the south branch consolidating, pushing onshore. So we'll see how that plays out. Anyway, so there we go. We're a week out. So basically the pattern is not a whole lot for storm production, at least looking at the jet stream. But precipitation, maybe not so bad. Next, we take a look at surface level pressure, surface level winds. And as expected, low pressure is here on the dateline, nestled in that little kind of pinched off trough thing there. 35-knot winds out of the northwest. Our secondary low or other low is off of the U.S. West Coast, sort of landlocked. 30, 35-knot winds pushing to the north. That's what's generating. We saw 20-foot seas. We'll put this into motion. Notice, as expected, the low sort of weekends falls south into Saturday night and Sunday, pushing into the U.S. West Coast. Low pressure continues north of Hawaii, 30-knot winds, and then it reorganizes into Sunday. 35-knot winds here again on the dateline as the system over the U.S. West Coast dissipates and moves inland. And then we get up to 40-knot winds on Monday, so more potential for swell production. Also notice here, high pressure, 1024 millibars. Low pressure, not much low pressure, 992 millibars. That's not much of a low. If it was down around 960 or 950, then we say that's a strong low. But it is the difference in pressure between high pressure here, circulating clockwise around the high, low pressure circulating counterclockwise, and because they are in close proximity together, that sort of tightens the isobars. That creates what's known as a pressure gradient, where there's two competing systems close to each other, and that's what generates wind. So we're getting 40-knot winds supposedly on Monday out of two rather meager a high and a low pressure system, but because of their close proximity, we get some fetch out of it and we get some seas. Again, 40 knots into Monday night. Into Tuesday, the system starts falling south to Hawaii, towards Hawaii. Hawaii is to be the main recipient of any swell that's produced here. And then the system falls south and falls apart. We move into Wednesday night. Another low pressure developing off of the central Canadian coast on Thursday. Not really much in terms of swell production, maybe precipitation production. And notice here, low pressure pushing off and moving due north, the split jet right there kind of thing. And high pressure in between the two split stream froze exactly as expected. Roll this out into Friday. Notice a bit of weak low pressure and pockets of fetch wind swell basically moving into the U.S. West Coast. Cutoff low sets up north of Hawaii on Saturday. Another low pressure here off the Kurils, but just not doing a whole lot. Oh, there we go. Oops. And a week out, there we go. A little patch of 35-knot fetch. So in all, not a whole lot for swell production. Weather production, at least that's going on for California. The culprit, of course, the jet stream and the MJO. Let's go take a look at significant wave heights. And here we are, significant wave heights. As expected, our little system in the Gulf of Alaska, the other one on the dateline, 20 to 24 foot seas. Little X right there, Here we go. Max significant wave height denoted by the plus sign, and you can get the exact coordinates and the size right here. And also maximum winds, you can see 37 knots, one little tiny grid square. So this model runs at, I believe it's a half-degree resolution. So that's there's a box or a sensor place where the model calculates wave heights every half a degree. So that's 30 nautical miles north and roughly 30 nautical miles east-west on the equator. Of course, those get smaller as you move north. So one tiny little area there of 37.7 knot winds, which is about 40 miles an hour. Anyway, rolling out, seas in this system fade out into Sunday, and also the system in the Gulf pretty much fades out. But then the system regenerates. We saw that 40-knot winds come into Monday, and we get seas building up to, what's that, about 26 feet or so, aimed pretty decently at Hawaii, but also at the U.S. West Coast. So a little bit of swell, and then we're up to almost 27 feet in one tiny little spot there. We'll call it 26 feet. Into Tuesday, the system starts falling south towards Hawaii. So, again, most swell is generated in the direction the system is falling or traveling. Big systems coming off the off of Japan, when you have a consolidated jet and pushing off to the west, tend to favor targets over here. Anyway, rolling out, the system falls south, 20-foot seas fades out by Wednesday, and that's pretty much it. But pretty decent swell likely for Hawaii. We continue looking for something of, at least give us 20-foot seas. Oops, and we went too far, and there is nothing. So pretty much that's it for now. 3 systems, one on the date line currently pushing to Hawaii, little system up here in the Gulf targeting the U.S. West Coast, secondary system redeveloping, really remnants of the first system redeveloping, again targeting Hawaii. All right, let's go take a look at some weather. So snow is really what we're looking at, but also rain. Hawaii's here, U.S. West Coast here, San Francisco area here, Lake Tahoe here, Mammoth down around here. You can obviously see low pressure that we talked about. A front moving down the coast, precipitation, moving into the San Francisco area at 10 a.m. according to this model. Looking out the window, the model is a bit behind. It's already drizzle in the San Francisco area. Moving on, that continues. We see snow building up in the Tahoe region by about 4 p.m., getting pretty heavy here, and we have a nice little trick we're going to show you here in a minute. But it looks like pretty heavy snow. Notice the whites here. That delineates snow, and we'll show it here. Down at the bottom is the snow scale here. The rain scale is over here, so they're both overlaid on the same image. Anyway, oops, here we go. Alrighty, roll this out. Pretty good snow. Look at that. That's pretty solid snow into Sunday a.m., reaching down almost, hard to tell, but almost to Mammoth and the southern Sierras. And then things start fading out on Monday. We'll just roll this out. Another little pulse, like a secondary shortwave, pushes through on Monday. Snow continues just maybe down to Kirkwood, and probably not a whole lot further, and then that fades out. High pressure builds in. You go, it's all over, and this is what the models suggested. But notice, another low pressure building up here. Lots of activity for the Whistler area and British Columbia. And then another front pushes down, a little bit of snow, higher elevations on Friday. That continues into Saturday, kind of weak precipitation. It builds up again on Saturday. Oops. And that's the end of that model. All right, now we dive into more detail. And we're going to zoom in just here on the Lake Tahoe region. So here's Tahoe. Here is select resorts in that area. You can see the accumulation, snow accumulations build. That's what this is all about here. We just roll through. This is the 1 hour model, and it actually looks pretty good. Sometimes this model gets kind of funky, but you can see the snow actually working its way down. And here is I-80. And there you go. You can see snow starting to move in about 5 p.m. on Saturday. Little bit, nothing too significant, light snow, and you can see accumulations by 8 p.m. on Saturday, maybe an inch at Squaw. Nothing really for Kirkwood. Sugar Bowl, the highest at 1.5 inches. Anyway, you get the idea. Roll this out, and you can just see how things progress into Sunday. let's say by Sunday, 7 a.m., we're talking almost 14 inches, 11 to 14 inches of snow for most resorts. We'll keep on going into Sunday. Now, this only goes out 36 hours, so there's not a whole lot there. Now, we'll do the same thing that previous one. This is the high-res NOM model. The first one was in 1-hour increments. It only goes out 36 hours. This one is in 3-hour increments. It goes out 84 hours. Same sort of picture into Sunday. And then this one we can get into, notice the secondary pulse here. This is what is kind of interesting. We had the main pulse into 10 a.m. Sunday. It backs off. Secondary pulse comes in Sunday night and rolls, continues snow Monday. And then finally, later Monday, things fade out. By then, we're looking at 29 inches of accumulation at Squaw, 24, 2 to 2.5 feet. Basically, where was, Sugar Bowl 27. So you get the general idea. And then we're out at 84 hours and things kind of dry out. Now, we've been talking about building a new model, a new snow model, GFS model, goes out 10 days. We finally have a working demo of it. We'll show it here. Basically, it looks like the same thing. Now, remember, if you go on our site somewhere, we'll show you the links in a minute. None of this is posted on the site yet, but if you're smart, you can hack the URL and figure it out. In fact, here we'll do I can't easily do it. Here we go. Cheater look at the URL right there, Tahoe Snow GFS. If you know how to hack the URL, you can figure out how to get to these models. All the currently the data is there. We just haven't updated the menu. We're still testing it out. But anyway, you'll figure it out if you look at the NOM models and look at their URL and then look at the URL for the GFS models. It's not rocket science. Anyway, so here we go. Saturday, 4 p.m. Snow comes in. Now notice it shows it a bit heavier and amps it up a bit. But this is in 6-hour increments versus 1-hour or 3-hour increments, and the scale stays the same. So we'll roll this out. We're into Sunday. Again, 28 inches. So there's good correlation here between the two models. And, the other cool thing on this, on any of them, you can see, notice the snow level here, 10 a.m. Monday. Below Auburn, and Auburn is pretty low. Now, the models in our estimation tend to overhype this a little bit, but still, it would not be unrealistic to see flurries in Auburn. Anyway, roll this out. And so things dry up come Tuesday. Total accumulation, 32 inches. Anywhere from, depending on where you are, North Star behind the crest, so it gets less. And then the other thing, the models, right on the crest, they tend to not show as high sometimes as what's down just a little bit lower. And you even notice that when you're driving over 80. At the very top, there's snow, but it's just like 3 or 4 miles down from the crest on the west side. There's actually more snow accumulation. Anyway, so then things dry out, and you say that's over, and we've been saying there was nothing for next weekend, and really we're watching the models, seeing nothing. And then, sure enough, now the latest run of the models get into 4 a.m. Friday, and here you go, more snow starting to show up. Now, not a lot, but continuous light snow, and then building into Saturday. This is a week out, and then quickly dissipating. We're at 198 hours out. And then more showers into Monday, and then we get out 240 hours. That's the end of the model. Total accumulations, 52, 54 inches. So anywhere from, let's say, about 50 to 54 inches for the Sierra. Not too bad. Then we play the same game for Mammoth. Mammoth is right here. We also have the Pacific Crest Trail crossing over, there we go, in Yosemite. Here we go. And you can, so the accumulations are there. Here is the Sunday storm. It fades out, and we'll see if there's anything else. So accumulations, we're talking 11 inches, and it says 7 inches at Mammoth, basically. And we'll see if there's anything out here. And here's the secondary storm coming in on Friday, dusting a little bit heavier, though, into Saturday. And there we go. Just roll it out. So total accumulations at Mammoth, a foot, 13 inches, and 21 feet up at the crossing. I'm sorry, 21 inches. All right, let's look at our long-term outlook. What's going on with the MJO and what's going on with ENSO, the El Nino Southern Oscillation? First up, we look at winds across equatorial Pacific, specifically in the Kelvin wave generation areas. So here is the Pacific Ocean, New Guinea there, and presumably, Ecuador would be right off about here. Current winds, this is from the TAO buoy array, actual wind sensors on buoys strung across the equatorial Pacific from 5 north to 5 south. Actually, might even be 2 north to 2 south. Anyway, east winds, trades in control across the whole region. The area we're really interested in is the Kelvin wave generation area from 135 east to about 170. So draw a little box in your mind, 5 north to 5 south, right in here. This is the area where if you get west anomalies in here, it can create a Kelvin wave. A Kelvin wave is, of course, is a pocket of warm water that if you have west winds or west anomalies here, that warm water starts forming into a little bubble, travels under the equator, down 100 meters, goes the whole way across the Pacific, impacts Ecuador, gurgles to the surface, and creates a warm, like a slick of warm water on the ocean surface. And if you get enough of those Kelvin waves in rapid succession, then you can get El Nino. Anyway, east winds in control, no west anomalies. Look here, this is actual anomalies, differences from normal for this time of year, and you see pretty much a neutral pattern here, and there's a lot of data outages now starting to show up. Some of the sensors are going down. In the east, there was westerly anomalies in the east. That is starting to dissipate now. When the active phase of the MJO was over here, but that's long gone now. And notice the inactive phase of the MJO, we know it to be down here over in the West Pacific, and east anomalies are in control. No west anomalies, no Kelvin waves, but no one's really expecting a Kelvin wave with La Nina in control. You'd expect that more in a normal year or a neutral year or in an El Nino year. We look to the forecast, wind anomalies. So this is the whole planet on this chart. The date line is here. 120 east is here, so the Kelvin wave generation area is roughly between these two tick marks going down. In February, we saw a little bit of a westerly wind burst, but again, it didn't even make it barely to the date line. And then inactive phase of the MJO started somewhere around mid-February. These blues are easterly anomalies in the Kelvin wave generation area. There you go. There's your scale. Current forecast right now, easterly anomalies forecast to start building pretty strong for the next 4 or 5 days, and then starting to give up some ground. So again, according to this, just eyeballing it, probably the middle of the inactive phase of the MJO normally runs about 3 weeks, so we're probably right about at that point or so. And so all this is expected. No westerly anomalies expected. Inactive phase of the MJO, just looking at this chart, is likely in control. So to confirm that theory, we look at other charts that project the MJO, what it's supposed to do. This is outgoing long wave radiation, that is presence of clouds, where there's more sunlight reflectivity, like right there, the positive numbers, more sunlight bouncing off the ocean surface. That suggests high pressure, suggests the inactive phase of the MJO. Less sunlight reflectivity, that'd be negative anomalies, like there. Blues, that suggests more cloud cover, the active phase of the MJO. According to this, the statistic model, the inactive phase of the MJO is to hold for the next 5 days, then start backing off, and then pretty much be gone 2 weeks out, with the active phase of the MJO moving into the West Pacific. The dynamic model is kind of weird, suggesting, and this is like the GFS ensemble model, suggesting the inactive phase of the MJO, just like the statistic model, is to die, but actually is to retrograde and then sort of regenerate 2 weeks out. That is certainly not the preferred outcome. We want to get rid of the inactive phase of the MJO, get the active phase in here, get the jet stream reconsolidated, and get something that resembles a decent jet, and then the opportunity to produce storms and therefore swell over the open Pacific Ocean. Next, we look at phase diagram charts. So assume you're looking down on the north pole of our planet. The MJO rotates counterclockwise around the chart and around the planet from the Indian Ocean to the maritime continent, consider Bali, that area. Over the dateline, West Pacific, under the U.S. West Coast is all on the equator, okay? Across the Atlantic, over top of Africa back to the Indian Ocean. The big dot is where the active phase is. If it's in the center here, it's very weak. The further from the center, the stronger it is. This is past history. See, we had a fairly strong active phase of the MJO back on the 8th of February, peaking out somewhere over the Atlantic on the 15th. Now currently, 3rd of March, very weak. Just outside of the cone of death, they call it. Here in the eastern Indian Ocean, the forecast is to try to move west, but be exceedingly weak. So that sort of favors that GEFS model we saw. And the same thing here. Oh, this is the GEFS model. Same deal, even weaker still. So no active MJO really discernible for the next 2 weeks, according to these charts. This upper level outlook, same sort of deal. The yellows are the inactive phase, but this runs about 2 weeks ahead of what actually is happening at the surface. This suggests the inactive phase 2 weeks out is to pretty much be gone. That's what we want. Here, this is the propensity for precipitation or enhancement of precipitation. The greens are the active phase, the MJO moving into the West Pacific. March 14th, so it'd be towards the end of March there, moving across the Pacific and pretty much gone by the end of March. So really you're into mid-April. Inactive phase showing up end of March, working its way and pretty weak, moving across the Pacific into mid-April. So that's the end of April. So sort of gives you a general sense of what's going on. But we prefer this model, the CFS model. It's a more specific, and this view specifically, it's a more specific view, okay? Past history is down at the bottom. Yellows, of course, are westerly anomalies. Blues are easterly anomalies. Here we are in the next 5 days, strong easterly anomalies. Oh, and a Kelvin wave generation area right there between those two tick marks going up. So on the dateline, strong easterly anomalies forecast. Probably the strongest we've seen for months. The final potential gasp of La Nina, enhancing the inactive phase of the MJO. In fact, we'll just overlay the MJO. There you can see it. Easterly anomalies associated with the peak of the inactive phase of the MJO. And here's where things get interesting now. Starting about March 19th, 18th, something like that, the active phase of the MJO comes in, and if you really look down here, you don't see any real westerly anomalies on the dateline. But according to this, after that, westerly anomalies start building on the dateline, and a little bit east of there, pretty strong, associated with the active phase of the MJO. And then here's the inactive phase that builds in supposedly in mid to late April. Westerly anomalies continue. Why is that? Well, we go to the low-pass filter here, take a look. So this dotted contour is La Nina. Okay, according to this, April 4th or so, it's supposed to die out. And over here is the area, you don't want to call it La Nina and El Nino because this is over in the Indian Ocean, but that we'll call the solid contour the area that's most supportive of precipitation and westerly anomalies. And notice it flops into the Pacific come about April 21st, and supposedly El Nino starts developing in the Pacific. Now, we're not going to really buy into that whole hog and believe it, but at least if it's even remotely like this, then that should favor westerly anomalies. That should favor the active phase of the MJO. And unfortunately, it's too late in the year for this year to do much for surf, but for the fall of 2017 and the winter of 2017, maybe a much more favorable pattern setting up. All right, we've talked about atmospheric links of the MJO and El Nino, La Nina. Now let's go take a look and see what's going on in the ocean. West Pacific here, East Pacific here. Actual temperature distribution, as you can see, most of our warm water here is in the West Pacific, 30-degree anomalies, and they've actually retracted, if anything, moving more to the west to like 158. They've been hanging around 165. The 28-degree isotherm has held steady, though, and actually is moving west a little, 177 or 176. But of more importance, the 26-degree isotherm, and this is centigrade temperatures here, was 2 or 3 weeks ago confined to no further east than 150. Now it has moved the whole way across, and actually you can see a little bit of 27-degree anomalies right here. And remember, in previous charts we saw westerly or almost westerly. There's been basically westerly anomalies in the West Pacific. That has basically suppressed trades, allowed ocean heating to warm the ocean surface here. We're not going to say Kelvin wave supported, and you'll see why in a minute. But certainly warming occurring in the East Pacific, and that is a good thing. More warming here, that supports, basically it suggests that La Nina is gone. Normally during La Nina you get enhanced trades in this area, lots of upwelling, a very shallow warm pool confined to the surface, and cooling, and that only exasperates the easterly anomalies, but that appears to be coming to a close. Differences from normal for this time of year. Another big improvement here. Now see, we have warm anomalies, 2-degree anomalies here in the West Pacific, but what we had was a pocket when La Nina was good of up to 4-degree anomalies. Last week it was down to 1-degree anomalies, but a pretty solid pocket. That is all but dissipated. One tiny little pocket here. Notice, for the most part, we're just going to call it neutral anomalies, a subsurface across the entire Pacific, pretty much suggesting the death of La Nina. And even more interesting, this other view from the GODAS project suggests stronger warming, and basically what looks to be, I'm loath to call it a Kelvin wave, but a stream of warm water moving from West Pacific to East Pacific, continuous with no cold water in sight, suggesting there is a pathway now for warm water to move, and it's starting to accumulate a little bit at the surface here, suggesting a return to a normal pattern. Now the issue is, it might be normal in the ocean, but it was colder. Okay, the atmosphere responded to that. The atmosphere is a big boat. It just doesn't turn around on a dime, so it'll take a couple of months. The change, we went and did some research on this. The change started, let's say, late January, so we're thinking sometime in late March. That's when it's about a 3-month turnaround for the atmosphere to figure out that the ocean's changed and for it to respond in kind. About a 3-month turnaround. So late March, maybe we'll see the atmosphere kind of wake up and recognize that a pattern change is in play. Here's a time-lapse view, upper ocean heat anomalies. This is the last little pocket, Kelvin wave number 6 from the El Nino from 2014-15. The onset of La Nina in 2016, colder water, the blues. Now moving into the current time frame. Notice here's our warm water building in the west. It'll store up, but also some of it seeping to the east, and just like we saw in previous pictures, warming building in the east. So pretty much the death of La Nina. One other view, ocean height anomalies. West Pacific here, there's New Guinea, South America, Mexico, East Pacific here. So negative anomalies suggest cool water at depth, like -5, this is 5 centimeters. This is strip out all the waves, all the wind swell, all the tides, and just look at the absolute height of the ocean. Where there's warm water, like here in the West Pacific, at depth, that warm water sort of expands. It creates a bump on the ocean surface. We're talking 5 to 10 centimeter bump, a couple of inches, but they can sort it out at that level. That's how precise this is. This is from the Jason 2 satellite. The interesting point here is, notice this right here, 0 to 5 centimeter anomalies building along Ecuador, working their way past the Galapagos out to, what is that, about 130 west now. Hawaii is right there, so not too far off. It's pretty much still in the Nino 1.2 region, but pretty much signifying the death of La Nina. All right, surface temperature anomalies, and here is just something even more impressive. Notice reds, lots of warming building along Chile, Peru, Ecuador, little tiny pocket of cool water here, but it's not making any real progress. Warm water over the Galapagos and on the equator, and notice it's covering an absolutely huge area here, 160 west down to 25 south. This is out, 4,000 nautical miles. The whole southeastern Pacific Ocean is warmer than normal and building here along the South American coast and starting to advect, driven by trades, off to the east A little bit of cooler water. What's this? Half a degree or so. Not, maybe the last little remnants of El Nino, and even warming building out south of Hawaii at 150 or so. So that is the major story. Now, we're not saying this is El Nino or anything, because this would have to go on for months, but it's certainly marking the absolute death of La Nina and a return to at least a normal pattern, normal temperature pattern, but certainly it appears warmer than normal, and we will be watching it. The trend for the past 7 days, and as you can see clearly, and we saw this even last week, and I think we saw it the week before, the oranges and yellows warming trend building off of South America, and there's sort of this line right here. You can draw sort of a box right around something like that there. Here's the center of the warming out to 160, we'll give it that. Notice this one little cool pocket here, another little pocket here, but by and large, warm water is the name of the game, or at least a warming trend, suggesting, well, remember, the active phase of the MJO pushed under here. We saw in previous charts that trades were suppressed in this area, so at least warming from lack of wind or normal winds, unless there's some other source. Interesting pattern, though. Here's the high-level overview, and of course, as expected, warm along the South American coast out here. Here's a last little pocket of La Nina. We're going to show you something here in a second. This cooler water was all streaming off of here 2 or 3 months ago. It's all gone, warmer than normal now. And here we go. We're back in December. Notice the cool water streaming off the Galapagos in time. And here comes the warm water about January 20th. And then it really started building into February. And there's the last little bit of La Nina. We'll see this. Roll this out again. This is back in December. And just watch this go. That's almost not and even that was a weak La Nina. I mean, it's dying here in January. Here comes your warm water. Notice all the cool water's pushing off and just basically dying. We're returning to a warmer regime. All right, so we've talked about the MJO. We've talked about El Nino, La Nina. We've talked about water temperatures in the Pacific, but what we haven't talked about is the atmosphere above it. What's the atmosphere's response to this change from a cool regime to a warmer regime? Well, in February, we saw, this is the Southern Oscillation Index, difference in pressure between Darwin, Australia, and Tahiti. When you have positive numbers for a long run, that suggests at least the inactive phase of the MJO, if not La Nina. Clearly, that was going on. You can tell this in the daily numbers back in February. They were in the positive range. You can also, the MJO is sort of reflected in this, but notice come about February 15th, we started getting very negative anomalies here. This was attributable, these minus 51, attributable to low pressure in the Tahiti area. That has moderated since, but still, we're in a pretty much negative regime. Notice this hasn't updated here in a day or two. But anyway, you get the general sense, negative anomalies. The 30-day running average, we go back here, we were at -1. Where are we now? We're at -2, -2.5. Again, the 30-day average is really good for watching the MJO. The 90-day average is good for watching El Nino, La Nina. We were barely positive. Now we're moving into the barely negative regime, and this 90-day average hadn't picked up any of this stuff yet. So pretty much neutral right now. In fact, let's go look at a graph. Here's the 30-day SOI average. So back in 2015, here was our El Nino negative numbers. You could see the pulses in the MJO here. The upward pulses are the inactive phase. The downward pulses are, of course, the active phase. And then the onset of La Nina here in spring of 2016. And then, boom, in November, we had this big active phase of the MJO. We got a bunch of surf out of that. Then things sort of moderated. Now we're on this slow, steady decline. About average, a little bit below average. But if we're in El Nino, we want to be down in at least the -15 range. We got a ways to go to get there. Then there's this other index, the ESPI index. It's basically the same thing as the Southern Oscillation Index, but instead of measuring differences in pressure between the area north of Darwin and the area north of Tahiti, it's the difference in actual rainfall. When you have negative numbers, the current value is -8. That means less rainfall than normal here. Positive numbers mean more rainfall for here. More rainfall here. This pretty much is equivalent to the Nino 3.4 region, which would suggest a turn towards a El Nino pattern. Right now we're negative. We're running deficit rainfall. You can see it here. This is rainfall anomalies for the last 30 days. Still drier than normal here, as to be expected with La Nina, but this was at minus 9.7 a week and a half ago. It's up to minus 8. The expectation is, remember we said 30 days till the end of March when we would see some sort of a change in the atmosphere. Now that also supposes that warming stays here off of South America and builds over this region and all that kind of stuff. And but the expectation is we're going to see this the SPI index turn to neutral or near neutral probably in the next month or so. Then finally, sea surface temperature forecast for the Nino 3.4 region, that same box we were just looking at. Back in April 2016, death of El Nino, La Nina, negative temperature anomalies here in the area from, was it 120 west to 170 west, 5 degrees north or south of the equator. Only half degree below normal. That's not much of a La Nina. Currently, we're in the March time frame. Temperatures, according to this, are half a degree above normal. We'll take a look in a second. But the forecast, as you can see, is steadily upward to 1.5 degrees. Now, this is probably way overstated. A consensus of other models says temperatures probably only in maybe a half a degree above normal, which wouldn't really be El Nino. That's why we're not saying El Nino. We're going to say a return to normal temperatures or biased slightly warm, which would be biased in favor of the active phase of the MJO, which would be biased in favor of more surf for the fall and winter of 2017. Here's actual water temperatures for the Nino 1.2 region. This is the area up there along the equator, right along South America and the Galapagos. And as you can see, temperatures are definitely working their way up. But, they need to stay warm for multiple months, not just for a month or two, but for 5 to 6 months for you to have anything that would be considered El Nino. But they've been above normal for a fair while, and currently 2.15 degrees above normal, is spiking up to almost 2.5 degrees above normal. So definitely a good sign here, but it is the Nino 3.4 region that really counts. And here's the Nino 3.4 region. Now here's where La Nina was back in December, negative anomalies. We're talking only minus at most, not even 1 degree, and averaging somewhere around half a degree or even 0.4 degrees. And then here's the warm-up that's been occurring as of recent, up to 0.8 plus 0.08 degrees. But kind of noisy, bouncing around. The warm water off of South America is still trying to filter to the west, so we would expect it to be noisy, and we just have to see what happens. It's going to take a couple of months to see whether all that warm water makes it over into this region, whether it continues to stay warm, or whether things return to normal. So to wrap things up, right now, swell pattern kind of weak, driven by the inactive phase of the MJO and a weak jet stream. Weak gale on the dateline, another one off the U.S. West Coast, and then another one expected. Really, the dateline one is to reform early midweek. Maybe some swell for Hawaii. Not a whole lot for the U.S., but something small, rideable surf. Probably the more important thing, more weather for the U.S. West Coast, more snow for the High Sierra. In the meantime, we're looking for the active phase of the MJO to make a reappearance, probably sometime in mid to late March. Probably not a very strong one, though. Might not have a giant positive impact on the jet stream, and we're just going to limp our way out of the year here. The winter season, swell season. The expectation is as we get into the fall of next year, perhaps a better pattern. This summer probably will not be a good one. The typical thing is when you have La Nina, the summer after La Nina, the southern hemisphere doesn't do a whole lot either. So we're just going to have to suck it up here. We knew that, though, coming out of El Nino in 2016. We thought actually things would be way worse than they are. Yeah, the surf hasn't been great. I mean, it's been a lousy year for Hawaii. It's been California has had its moments, but by and all, it's been kind of slow. And we knew we were going to have to pay the price for 2 years of El Nino, but the price we've paid really hasn't been that bad. The upside is there's been snow, and if you're into boarding or skiing, that's a good diversion. I hope you've made the most of it. More coming. You saw the models. So in general, more of the same for now. Get snow while you can. Hope for the best, and get your training regimen in shape, because the expectation is by next fall, we'll probably be into a much more positive pattern. So that's it for this week. We'll do it again next week on Sunday. See you then. Thanks for watching.